A painter is painting n walls and has this phi, where n is the number of walls, k is a constant, L is the length of the walls, and h is the height of the walls. If we're changing the brand of paint, which variable could that be? Well, that's going to be this unknown constant with units of dollars per square foot. None of the others make sense. So we have a function which is the same thing as y equals mx plus b, and the slope is always the m, or the coefficient of x. So our slope here is 9/2. In this equation, x represents the number of minutes Maria spends running, and y the number of minutes she spends biking. So 75 is the sum of those two. So I see this word total, and that makes a lot of sense. We have an equation for the average number of students per classroom at a particular high school. And since this slope is positive, that means the number of students is increasing. And the slope is always the coefficient in front of the variable, and what we started with is the number or the constant all by itself. So we're looking for an average number of increase, or average yearly increase, which is down here. We have 0.075x, which goes with light A, and we have 0.06y, which goes with light B. So the number 0.075 is the coefficient of x, and that tells you the number of lights. Well, you multiply by the number of hours that light A is on, and it tells you the amount of energy that is used. So we can cross out these because they're about light B, and this is the correct answer. This one is about the price of a job for a landscaping company. Here's our expression. $60 is the initial charge just for showing up. And we see 12 with two variables, n, the number of hours, n, the number of landscapers, and h, the number of hours. So what does 12 mean? Well, it's being multiplied by both hours and landscapers. So the answer is A, because it's per hour for each landscaper. We're multiplying by both. So in this problem, we're talking about a printing job that there's two printers. One is a slow printer, the other is a fast printer. One is twice as fast as the other. And the job is done in 5 hours. So this tells us the progress for each 1 hour, or 1 out of the total 5. That's where the 1/5 comes from. We can also just add together the 1 and the 2, because that is the same denominator. And if we cross multiply, we get that 15 is equal to x. Which then we could figure out that it would take 15 hours for the slow printer, or 7.5 for the fast printer, but the combined is 5 hours, but they only want to know about this first expression. So since we're still looking at 1/5, we're looking at how much can be printed in 1 hour out of the 5. And B shows that this first part is talking about the slower printer, because it has a 1 instead of a 2. So here we have our one-time fee, and then we have an hourly rate. So the slope of the graph, which is the dollars per hour, is going to be the hourly rate. It's not the total the contractor charges, because that includes the one-time fee. It's not the one-time fee, that's the intercept. And there is no maximum amount here. So in this line graph, we see over time how many students completed summer internships. If we compare that with this table over here, we can see that in 2008, we are looking at 87. In 2012, we're looking at 70. So it appears we are only looking at foothills. We're ignoring valley or the total. So valley is no good. From both is no good. Total number, it's just A. Foothill High School only. If our formula is P is equal to 108 minus 23D, and we are repairing a batch of phones, it's 23 per day. What does the 108 mean? How many you start out with. And this equation represents each week's worth of work. So that's why it's each week you start out with this constant value that does not change, one time.